Today we are going to discuss one of the most confusing topics which is asked in many interviews, that is eigenvalue and eigenvectors. People usually leave this topic because of its complexity in understanding. Okay, after today's video you would be able to explain to anyone what eigenvalue and eigenvectors are. I request you not to skip the video, you may miss very important concepts. Let's consider the multiplication of a matrix and a vector. Okay, this is how the matrix looks like. This is our matrix and this is our vector. Now, this is how the multiplication of this matrix with this vector looks like. So I hope you all know how to multiply matrix with vector. Okay, if you don't know, you can Google. I'm not covering matrix multiplication in this video, but you can always Google. Now, this is what a resultant we get. Okay. Now, if I have to plot the resultant, same like we have plotted our vector. Okay. So our resultant is in red and reads 319 and our vector is 13. As you can see, we can say that our resultant is nothing but the original vector which has rotated with the angle theta as well as scaled. Now keep this thing in mind. We have introduced this in case 1. Let's go ahead and see case 2. In case 2 we have the same matrix and we'll multiply it with another vector which is 1 4. Earlier we had 1 3. Okay, earlier we had 1 3. Now we have 1 4. Okay, now I have plotted this vector and now going ahead we will multiply these two and plot the resultant. I am doing the multiplication. Now this is our resultant. Okay, I have plotted it here. Now you can see resultant is nothing but the scaled of our original vector without any rotation, because there is no rotation of the original vector. Okay, it's only scaled. Okay, so if I have to sum up both the cases, can we say that in case 1 our vector rotated as well as scaled? Okay, rotated as well as scaled. Okay, in case 2 it did not rotate but only scaled up. This is the conclusion of both the cases. Okay, now let's sum up. Okay, now if I tell you that vector that undergoes pure scaling without any rotation is called eigenvector and the scaling factor is known as eigenvalue. Still confused? So let's reiterate with our example. Our case 2 was, this was our vector in case 2. Okay, and this was our resultant. Can I write the resultant in the form of our vector as, if I take the 6 as common, I get our original vector. Okay, so what I can say, our resultant is nothing but the scaled version of our own vector. Okay, now as we can see, the scaling factor is called eigenvalue and the vector that undergoes pure scaling without rotation is called eigenvector. So in our case, that vector is none other than this particular vector. So our original vector only did not rotate it but only scaled. Okay, so this vector is nothing but our eigenvector and this scaling factor is eigenvalue. Okay, that's all. So usually in books you'd be seeing lambda x. Okay, this x is nothing but eigenvector, this lambda is nothing but eigenvalue. Okay, this is scaling factor. Okay, so this denotes the thing only what we have seen in our cases. Okay, this is matrix, this is a vector, and this is scaling factor, and this is the same vector. Okay, right, these two are same. Okay, so whatever we have seen, it is same. Okay, now you know what eigenvector as well as eigenvalues are. Now you would be able to explain it to someone. That's all in this video. We will continue with another video. Keep watching and do subscribe. Thank you.